Let us begin with the fundamentals of visualization. What you see on the right side is a pictograph or a bar chart prepared by students in a kindergarten class, 4-year-olds, at the St. Luke Catholic School in Mississauga. This bar chart presents the frequency for transportation modes the kids have used to come to school. Some have been dropped to school by car, others by bus, and 2 students walk to school. In the brave, big world of big data, we can see that children are being trained at the earliest possible age with data and data science. The most important thing to realize is that the type of visualization you will use depends upon the type of variables you're trying to analyze. For instance, if you're working with categorical variables such as gender, you have to rely on a certain type of charting tools than if you were to be working with continuous variables such as age and income. In one case, you may be using bar charts, in another case, you will be required to use scatter plots. I would like to draw your attention to the extreme presentation method developed by Dr. Andrew Abella. Essentially, it lays out the possible ways of depicting data based on what kind of variables you have at your disposal. This visualization, this graphic, is developed by Dr. Abella that shows that if you are interested in comparing variables or demonstrating their distribution or composition or the relationship between two variables or more, you have to rely on specific type of graph. If you're comparing items with few categories, you can use bar charts or column charts. If you are comparing behaviors over time, and if you have the time periods running into months, several months, you may have to use a line chart. And if the time periods are not that many, then you can use columns and other approaches. If you're trying to depict relationships between two continuous variables, your choice is a scatter plot. The bubble chart will depict two variables on x and y axis, and the third variable will be depicted by the size of the circle. So you can essentially have 3 variables. If you're interested in depicting the distribution of the data set, you can use the histogram, which could be a bar chart type of histogram or a line histogram, and the distribution could also be shown through scatter plots. If you would like to show the composition, and if it's a static data, you can use pie charts. If you're showing the composition that changes over time, for few periods you can use stacked columns, and if you have several periods, you can use the stacked area charts. When you're working with SPSS and the very first time during a session you would like to create a new chart, the first dialog box you encounter is in fact an information or sort of a warning, and it says that before you use this dialog, that is a chart builder dialog, make sure that the measurement lever should be set properly for each variable in your chart. That is, if it's a continuous variable, it must be scale or should be set as scale. If it's a ordinal variable where categories are in a particular order, for example, number of children per household, 0, 1, 2, 3, or 4 could be the possible values, the variable has to be defined as an ordinal variable. And in case if you have a categorical variable such as gender being male and female, and in SPSS if it's coded numerically as 1 or 0, then those categories have to be labeled properly. So when the software displays these graphics, instead of showing 1 and 0 for the variable gender, it should depict a male versus female. If you were to recall the dataset we have been using so far, this is the teaching evaluation data from University of Texas, where we have attributes of the instructors and the teaching evaluation scores and other relevant information about the courses. Notice that the variable's name, for example, if a person or instructor is a visible minority individual, is given, and also the type, if it's a string type, which means that it's not a numeric variable. It is coded as yes and no as alphabets rather than 1 or 0. And notice that the same variable, minority, I recoded it as vismin, called it visible minority or vismin, and coded it numerically, so it's 1 or 0. And then I labeled it as visible minority, and then I gave it values 0 and 1. I did the same with gender, which was originally a string or a character variable, and then I recoded as female, 1 being female, 0 being males, and Instead of being string, I converted it into a numeric variable, gave it a value label, and then I coded this variable as 0 and 1 and proper attributes and labels attached to those categories. In both instances, the variable remains a nominal variable, either as recorded as numeric or recorded as character. It is a nominal variable. I would suggest that you pay special attention to type and measure and define your variables or code them under type in a correct fashion and then define them correctly under measure. And if you were to do this in advance, the effort you will require to generate your visualizations will be far less.